faculty. I'm one of the guys helping out with the speakers. We're going to have Andy come up and share some information with you. Andy's been around for a while. He has 20 plus years of experience in developing systems, engineering, administration, and architecture. He's currently involved with Dallas Hacker Association and the Shadow System Hacker Collective. So he's going to more or less talk about some things relating to, ironically, just the opposite talk of what you just kind of heard a little bit earlier here prior. So without further ado, Andy, for sure.
Thanks guys for coming. I really appreciate it. Again, my name's Andy Thompson. What we're going to do today is do a proof of concept of a golden ticket attack using PowerShell Empire. I was able to cut this whole thing down in about 6 minutes. It's POC 6 minutes, but it would have been 4 if I wasn't so bad at typing. Also, I didn't find out that tab autocomplete worked after I got done recording it, so you can do these sort of attacks much faster than the way I'm doing it. So anyway, a little bit about myself. I'm a strategic advisor at CyberArk. It's an awesome gig where I work with lots of customers, tell them about best practices and things like that. I have a bunch of certifications to make me feel better about myself that don't actually make me do my job any better, but I'm happily married. I have 2 little girls at home. I'm a member, again, of the Shadow Systems Hacker Collective and Dallas Hackers Association out of Dallas, Texas. Just a disclaimer here before we begin. There's 3 things I want you guys to be aware of. 1, the attack that I'm about to demonstrate didn't actually happen like it did in real life. We're going to be demonstrating the Bangladesh bank heist, so that's 1 thing. 2, there's more than 1 way to skin a cat here. In fact, there's lots of different ways. Even within the exploitation framework that I chose to use, there are more than 1 way to do the reconnaissance. In particular, I think User Hunter is an incredibly powerful module that would have shrunk my recon down to like maybe 2 steps, but it didn't work in my POC. So you have to go through different ways to do your attack possibly. So 1 method won't always work. And then lastly, if you guys came here to see some elite hacks and 0 days dropping, I'm sorry to disappoint you. I often say that calling me a script kiddie would be an insult to script kiddies, okay? Seriously. The whole point of this concept, or this talk that I wanted to demonstrate, is the fact that doing a golden ticket attack is so simple, you don't have to be a 400-pound hacker in your parents' basement to do this. So, Kerberos. Kerberos is the real facet behind the golden ticket. It's what runs the authentication and access in Active Directory. Think of it as the ticket taker in a movie theater. He's the one that can tell you what you can go see and for how long. That's the ticket that you're being given. What we're going to do is become our own ticket granting service and write our own golden tickets. So we can then have any access we want and for as long as we want on the network. So now it's story time. Imagine right at almost a year ago, February 4th, 2016, in Manila, Philippines. The gentleman walks into a very crowded casino, walks up to the counter, and makes a withdrawal request. They check his credentials out, his transaction checks out, it's a little big, but they load his backpack up with a large sum of money and he disappears into the night. Over 2,000 miles away, the central bank of Bangladesh has been robbed for $81 million. This was just a much smaller part of the attack. It was actually going after $951 million in SWIFT transactions. And unfortunately, this gentleman right here had to take the fall for this. This is Atur Rahman. He's the governor of the Central Bank of Bangladesh. He was the one that had to take the fall and actually ended up having to retire in disgrace because of his lax oversight of his cybersecurity program. What ended up happening was the Federal Bank of New York actually caught a transaction that was a typo, and they were able to stop the 5th of, I think they had stolen, this was for $20 million, and stopped it. The typo was the fact that they had spelled foundation incorrectly. They had actually spelled it like this, fundantium. And it's pretty easy to pick up when you have human eyeballs looking at the transaction. So, like I said, this was a SWIFT bank transaction. SWIFT actually stands for the Society for Worldwide Interbank Financial Telecommunication. This is a consortium of banks and institutions developed in the 70s to facilitate banking transactions. There's currently 11,000 users on the system, and they process over 25 million transactions today, per day, typically all wire transfers. So there's a lot going on as far as transactions and oversight go. They were actually a victim of what we call an advanced targeted attack, the Central Bank of Bangladesh. What's really funny is FireEye ended up doing an investigation on this particular attack and found out that at the exact same time, they were the victim of 3 parallel APT attacks. The Iranians, North Koreans, and this Asian crime syndicate were all in the central bank of Bangladesh at the same time. It was just the crime syndicate that pulled the trigger first on their in-game activity. These are in direct contrast to the other types of attacks that we see in today's organizations. Mostly denial of service attacks, opportunistic malware attacks like ransomware, and these are what we call quick targeted attacks. You know the guys that call your parents saying they're from Microsoft and you remote into your computers? That's that type of attack. So, the phases of the attack. Now, a lot of you are going to go, Andy, come on, this is like 101 hacking stuff. Well, you're absolutely right. The point I want you to take away from here is that the phases of an advanced attack directly correlate to the penetration testing phases as well. It's just that these advanced attacks have a significantly longer runway in their attack, where a typical pen test engagement might be 3-4 weeks, like 20 days. These guys have 2,000 days. They can be there as long as they want, digging in, finding all the stuff about the network out. So their runway is a lot longer. But the phases themselves are all the same. And the phases are such: external recon. Sorry you guys can't read this very well. Is it? You don't see it okay? Okay, well, just listen right.
If you turn the lights off.
Well, all these slides will be available online too, so. The external recon is the first phase, learning about your attack, your target, and then followed by the breach. And there's so many different ways you can do it. The USB dead drops, macros, exploitation of services, you name it, just getting your foot in the organization. Once you get your foot in the organization, it's time to expand. Find out what sort of access exists out there, who you need to have access to, and how to go about doing that. So once you know a little bit more about the reconnaissance, it's time to land and expand. So go out and find the access, get the credentials that you need in order to execute your activities. Once you do that, you follow suit with the domain compromise. This is where the golden ticket attack comes into play. What we're doing with the golden ticket attack is we've established our permissions. Now it's time to establish permissions to own the network. Once we've actually owned the network, we've got the permissions we need, it's just a matter as simple as executing your in-game. Doing whatever you came there to do. Whether it's shut the system down, corrupt the integrity of the file system, or whatnot. That's where the in-game comes into play. In this circumstance, we're going to corrupt the integrity of the Swift batch job file transactions by inserting our own transaction into the queue. So, the first phase. In this example, we're going to do the breach. And what I chose to use was PowerShell Empire and nothing more. All built-in modules, tools, and components with PowerShell Empire. So what we're going to do is create a malicious payload. I chose to use a malicious macro. I embedded it in my Excel spreadsheet. The end user double-clicks on it, the macro executes, and calls back to this command and control server. What you'll see here is the action showing that the agent has connected. And then all you have to type in is interact and the agent name, and then you have basically a shell running on that machine. Unfortunately, this particular user required escalating privileges. We need to bypass the UAC. So there just happens to be a module for that. Bypass UAC. Yeah, if you run that, click execute, and another shell comes back online. It's the same machine, but you have escalated privileges. This user happened to be a standard local admin on the machine. So now we actually have an elevated shell on that same machine. It's just a Windows 7, Windows 10 box, whatever you have in your enterprise. Now we move to the next phase. We've got our foothold in the organization. Now let's find out what we need to get. Our end goal is to try to get to another server that may have more privileged accounts on it. What we really want is a domain administrator. Those are the guys that we want to hunt for. So what we want to do is we want to query the network, query Active Directory, find out where those domain administrators are and what systems they're logged on to and what machines we can pivot to. And there's several tools that are built into the PowerShell and Empire framework that can allow for us to do that. But you can also use the power tools from the same people that develop PowerShell Empire. Also, Nmap's a great tool for this sort of recon, and you can develop your own with some command line kung fu. And this is what the phases of this particular POC will look like. Catch my breath here. So we're going to go back into the command line. We're going to find the agent that has the escalated UAC privileges and interact a session with. So we connect, and now it's a matter of running particular modules. The first one we're going to do is get group members. We're going to define that the domain administrator security group is the ones that we want to pull and find out who are our targets. This is a very small POC, so it came back pretty quick. There was only 2 domain admin accounts. One, the standard built-in one, and one by the name of domain admin. So those are the people we want to go after. The next thing that we want to do is find a list of all the possible targets that we can laterally move to and compromise. So the next command that we're going to want to use is called get computers. What it does is it queries Active Directory using read-only and provides back a list of all computer objects. So if you're in an established organization that has a lot of computer objects that may not be live and they haven't been removed, you'll get a lot. We were only provided 5. But I found that the 2 servers that you guys want to be interested in is File Server and Swift. Swift has all locked down. You cannot get into it. But file servers and print servers I've typically found have differing NTSF permissions than standard application servers because there's so many different outliers and exceptions to it. So now we've figured out that the file server is the target we want to go after. So we're going to run the command get local group. And we want to find out who the local admins of that particular file server are. By defining that server, that security group, we run the execute, and we're provided a list of all the local admins on that remote server. So we also found out that our standard user happens to be a local admin on that system as well. So that means it's a great candidate for lateral movement to that file server. The next thing we want to do is run a command called get logged on. This is really cool because we can actually see who's currently got logged on that machine, which also means their hashes are on that machine. So when we run get logged on, defining that particular file server, we're provided a list of the people that are currently logged on to that machine. One of those is the domain admin, who may have a session, may have logged off, but just means that that hash is on there, which means that that's going to be how we're going to keep going with our golden ticket attack. So here's the next phase, the lateral movement. What we need to do is we need to move from that standard Windows 10 machine to that file server. What we'll do is then we'll look for the credentials and the hashes that are stored on that machine, and then rinse and repeat. Steal those credentials and then laterally move to the next machine and do the same thing. You can use a lot of different tools for this, but we chose to use PsExec and Mimikatz for the password dump. Let's see. Come on. All right. So the lateral movement phase. There's lots of different ways to move within PowerShell Empire. You can use WMI, DLL injection. Let's see, PS remoting, PS inject. There's tons of them. I chose to run with the invoke code, I believe, invoke command. Copy and paste a script that's outputted to a text file. You interact with the single machine that you've already compromised. It calls out to that new file server, and that file server will then call back. You'll notice coming up here that a new agent will have connected. That is the file server connecting back to the C2 server. So what we're going to do is we're going to interact with that particular file server to demonstrate that we have successfully laterally moved and have that new shell on that file server. Type in who is, and you'll see that host name, and you'll see that we're connected to the file server. However, when I run who am I, you'll see that I'm still a standard user. I haven't escalated or stolen any credentials yet, which is the next phase of this, in that we need to harvest the credentials. And it's super, super easy. So what I'm going to do is I'm going to connect back to the system. We're going to show the credentials. I don't have it. I use the command Mimikatz. It loads it into memory. Most signature-based AV will not find Mimikatz in memory. However, some of the next gen will, so be aware of that. Once we run Mimikatz, it dumps the hashes, and we have our passwords in hash and in clear text value. So now we have the domain admin's hash. It's just a matter of using the pass the hash command, stealing the process, or the token ID, and now we have a process running as domain admin. We can do whatever we want, just like a domain admin could, which leads us to this next phase. We have domain admin rights. What's the next thing to do is, well, do the golden ticket attack. We need to steal the Kerberos hash. That's the one hash that's truly the keys to your Active Directory kingdom. That's the ticket granting service. Once we steal that Kerberos hash, we can generate all our own Kerberos tickets. And once we generate our own Kerberos tickets, we can establish permanent persistence on the network. Once we do that, let's go dig around for that Swift server that we previously couldn't get access to, and move forward from there. And it looks like this. Back to the shell, We will connect to our agent. Oh, I'm sorry, no, we're already in the agent. It's just a matter of using Mimikatz, again, to do what's called a DC sync. We're impersonating the domain administrator, saying, hey, domain controller, I'm a new domain controller standing up. You need to sync your credentials with me, but all I really care about is the Kerberos hash. You mind sending it my way? Okay, cool. So we did. We ran the execute of the DC sync, and we're provided with the Kerberos hash right there. So now we have everything that we need to produce that golden ticket. And it's very simple. Mimikatz and these guys have already done all the work for us. Like I said, it's so easy that I can do this. So what we do now is go back into the credentials, the Mimikatz module, and use the golden ticket module. There's a couple things that you could set up as far as defining usernames and things like that for systems. I chose the name Hack the Planet for my golden ticket. So I press execute, and I am generating a golden ticket. I have officially owned the network. Right there. So now it's really time to play with our golden ticket. What do we do? What we need to do is previously we couldn't access that Swift server and the file contents, and now we've provided a list of all the hundreds or millions of wire transfers going through that batch process. Now it's time for our endgame, executing our last phase of the the advanced targeted attack. What we've done is we've accessed the Swift server, we found the transaction files, and we're going to inject our fraudulent transaction. So this is outside of PSE, but you can see these are all pending jobs right here. And we'll open one up, or we'll just go back to the shell, and we're just going to show you the malicious log. Now this is actually what a real Swift transaction looks like, with the properties and whatnot, except for the fact that Shadow Systems has $50,000 coming to it. And it's just a matter of uploading the file. So once the file is uploaded, again, it would have gone faster if I could type it with that. But we upload it to the file server in that directory, thus either overwriting an existing file with no consequence or creating a new one. There it is on the Shadow System server, or the Swift server. So $50,000 richer. There's just one last thing to do. Profit. So I've demonstrated the golden ticket. And I think if you came to the last talk on how to defeat a lot of like the PowerShell Empire, Bloodhound things, a lot of those things, attacks could have been mitigated. But I'm going to provide you guys with a couple other ones. I'm not going to be all salesy, so I'm going to go pretty quick through these. But from an endpoint perspective, removing local administration privileges, removing that local admin right is critical, because you can't do a lot of the reconnaissance that you otherwise could have without local admin. Plus, you can't install a lot of stuff either. Also, controlling of applications, blacklisting, blacklisting, very, very powerful stuff. From an infrastructure level, patch your systems, guys. Patch your systems. You can't exploit vulnerabilities that have been remediated or just don't exist. So, patch your systems. Also, network segmentation is incredibly powerful. If you can block access to your critical assets, you can't access them, obviously. So, you can't do that sort of reconnaissance and lateral movement to zoned off assets. And to circumvent that from an administration privilege, we recommend using jump servers, proxy bastion hosts, as we call them. And they're very valuable. And if you want more information, Microsoft has a white paper called the Red Forest that outlines all these recommendations. From a credential perspective, this is kind of a cool concept called credential boundary, or credential tiers. And that's where you have admins that only work on certain platforms. So a workstation admin. You will never see that workstation admin on a server. Same thing, you don't have a server admin hash, you have a server admin boundary, that if you ever see that hash on a workstation, that means that hash could be used to move up from the workstation tier to your server tier, and especially your domain admin level. That level is up top and should never be on anything other than domain controllers, because that way, if you have any sort of like SIM that can detect those sort of credentials logging on to non-domain controllers, that can fire off alerts and you can take action based on that. Two-factor is incredibly powerful. You have to really provide that second layer of authentication or authorization to provide real good security. So we highly recommend access to operating systems, applications, really your tier 0, your critical infrastructure needs to be protected through multi-factor authentication. Secure and manage privileged credentials. Every application operating system has that super user account. It may be local admin, maybe root, maybe enable, but those need to be unique values, because if they're the same on any two systems, That means we could do what we just did in this attack and laterally move from one system to the next. Setting alerts on malicious events. Being aware of the behavior in your network is incredibly powerful, because if you know what's going on, you can take action and remediate those things. So be aware, set alerts so you can detect the DC sync happening from anything other than the domain controller that you have authorized. That would have helped stop. Monitoring behavior to detect anomalies. If that standard user would have fired an alert if we remoted into that file server, they never had before. Be aware of that sort of heuristic behavior. And then lastly, monitor the privileged users. You know, if you see a domain admin that's logged on to any other system other than one they should be, you need to monitor that stuff. And there's tools that will record the privileged sessions out there. So that's really kind of the talk in a nutshell. That's what I've got for today. Are there any questions that I can answer at this time?
What are some of the tools that monitor the privileged sessions, if you don't mind?
That is something that I'd be more than happy to answer. I work for CyberArk, and we do sell something that does that. But, again, I don't want to be a sales guy, but we do have a tool that can actually record all the sessions that are done with a privileged account. And it can be like a TiVo, where you can fast forward in, you know, on a 6-hour RDP session, you can fast forward to like 3 hours in when ran regiments. So that would be a good tool. And you can build your own too, but I recommend something like privileged session.
Yes. So understanding the cyber part of this, the tracking the funds that were exfiltrated or moved, how is that not possible?
Well, what happened was
With the SWIFT transaction,
yeah,
that's a secure system that it knows the source and destination.
right. They went into shell organizations and were channeled through the casinos, which were then basically money laundering with the funds. So that's why the transactions were mostly routed through the Philippines and Shenzhen, China.
So the SWIFT system itself isn't secure.
No, the SWIFT system was actually secure. It was the banking organization that housed the SWIFT network. Because they didn't have two-factor on the SWIFT network, they were able to compromise the bank, but SWIFT is sound. SWIFT is sound.
It was in essence the endpoint wasn't money was going. You need to trigger it without everything from SWIFT worked perfectly. They did after the supposed to.
It's just there was no oversight of the transaction. Nobody saw the transaction go through until the Federal Bank of New York caught the title.
DTC.
All right. Well, thank you guys for coming and listening to me. I do appreciate it. Thank you.
Andy, where can we find the slides at?
I'm sorry?
Where can we find the slides at?
SlideShare.
I appreciate it. I'll see you.